morning. We are going to start very soon. I'm just going to make sure I've got these bits. The 10, actually, if you can make that more than 10, like maybe 15 or 16 blocks or loose parts would be great. Bits of Lego would be perfect. Make sure you've got a calculator, something to write with, something to write on. That would be awesome. I'm going to do that now. And then you can take a look at this question. What is the average colour and how do you know? What is the average colour on that picture and how do you know? Okay, I will be with you very, very soon. Just got to sort out a couple of bits. Yes, looking pen. Perfect. Good morning, Maths Mom! Oh, I'm so excited. Do you know what we're doing today? We are decorating our Christmas tree. So I'm super excited about that. Woohoo! It is, well, actually, if you're watching the recording, that'll be a bit weird. It is December. I'm Ruth. This is Joyful Maths with Ruth. You are currently watching one of my free GCSE/functional skills maths lessons where we're looking at foundation, GCSE maths, functional skills 1, functional skills 2. And we're currently looking at data handling. So we're looking at averages today. Some of this is not required for functional skills 1. I'll be really clear about that when we get to those points. We'll start off with those bits that we do need for functional skills 1 and then move on from there. I asked you a question. Now, you can't put comments on this because this one's on YouTube, but I asked this same question on Tuesday on Facebook, and some people said there's no average on that graph, and some people said that blue was the average. I'll show you the graph again. And then we're going to come back to it. I'm not going to give you I'm going to hold you in suspense about what the answer is. Okay, so here, this was the graph. And I said, what is the average colour and how do you know? Some people said blue. Some people said there isn't an average and you can't take an average here. Now, the thing about averages, it sort of relates to maths in general here, is that we've got words like average that we use commonplace in the English language all the time to mean really specific things. And then some of those words are actually mathematical words that have a very specific mathematical meaning, and they don't always tally up together particularly well, which is really confusing. This is why maths is, alongside being a skill-based subject, is also like a language that you have to learn. Average, sort of in everyday terms, most people think of average as being, say, sharing something out fairly, and it's a particular type of average that we call the mean average. But if I was to say, for example, the average dog or the average car, probably you would think about like the most common 1, which is another type of average. It's just that when we use the word average in English language, we don't think about it like that. There's actually another type of average as well, which we're going to talk about, which is like middle average. An example I was using on Facebook was like house prices. If I talked about, and this often gets talked about in the media, average house prices, often if they've taken the mean average house price, it might be a good reflection in some areas of the country of the average house price, but it's going to be skewed by some houses being extraordinarily expensive, but not very many of them. It's also likely to be skewed by some that are very cheap, and again, not very many of them. But depending on how far away they are from that average is going to skew this data, which is why we need these different types of averages. It's also different parts of the country might see different trends. So we have to be really specific with this. Right, let's look at some of the mathematical language then. So there are actually 3 types of average. There's one where you're talking about the most common. So this is where I was saying about dogs and cars. If we were talking about the average car, the average dog, you would probably think about the one you see the most often. We actually call that the mode. The middle, the one that you see in the middle, which is possibly fair with house prices, we're looking for the middle price, we would call the median. These 2 you don't need for functional skills 1. The only one of these you need for functional skills 1 is the mean, which is probably what most people think of when we say average. This is the one where we share it out really fairly. Okay, so if I ask you what is the mean colour of these colours, yeah, I mean, it makes absolutely no sense whatsoever. If I say, can you share those colours out fairly? Well, we would start off mixing them all together and then we try and share them out fairly. The problem is they're no longer the colours that they were anymore. They would mix together and make brown. So in this case, if I'm asking about the mean average, so if I was saying what is the mean colour, makes no sense. To find the mean, really, we need some numbers. We need to be able to like share this thing out in a number way. Okay, so I've got a little problem for you. If you've got, let me just count up. 5, 6, 7, 8, 9, 10, 11, 12. If you've got at least 12 little Lego blocks or loose parts of any form, you'll be able to do this one physically. Otherwise, you might be able to like visualize it. So I'm going to show you this. I've got 3 people. There's Tammy, Sally, and Rowan. Tammy has got 5 sweets. It doesn't matter what colour sweets they are. It's just to show you who's got what. Tammy's got 5 sweets. Sally's got 4 sweets. Rowan's got 3 sweets. I want you to find the mean number of sweets. How many would each of them have if you shared them out fairly? How many would each of them have if you shared? It's quite a good question. The reason I've got sweets on the brain is we do have one of these advent calendars where you stick your sweets in, and I've just been delivered mine for this morning, actually. So when I was planning this, I was thinking about my advent calendar at the same time. Right, I'm going to be quiet whilst you have a little think about that and settle my little Lego blocks. Okay, I don't know how, I sort of think maybe you've probably been able to do that by now. Let's have a little look. I'm going to show you my little Lego blocks here. All right, so we've got, Tammy has got 5 sweets, so I've represented that with 5 Lego blocks. Sally's got 4, and Rowan's got 3. So they've got different colours, basically. But it doesn't matter about the colours. It matters about the number of sweets. To share it out fairly, I might have spotted that if Tammy just gives Rowan 1, everyone would have 4 sweets. So in that case, the mean average, the mean, would be 4. And another way of doing that would be to put them all together in one big group. So essentially, we're adding them all up. So we've got 12 sweets there. And then sharing them out equally between the 3 people. So I would divide that 12 by 3 to show that I've got 4 each. Okay, either way of doing that, everyone ends up with exactly 4 sweets. What happens though if Vinny comes along, and you can see Vinny is like, how's this going to work? Vinny's come along. Vinny has got 1 sweet, but we're still going to share it out fairly. Okay, so Vinny's got 1 sweet. what's going to happen now? How many are they going to get if we share this out fairly? How many are you going to get? This might be a little bit more complicated. Find this one a little more complicated? I had various different answers on Facebook. I'm going to talk through all those different answers, actually, because they were all spot on. But it's interesting how they were all presented differently. First of all, let's have a look with our blocks. So again, I've got Tammy's got 5, Sally's got 4, Rowan's got 3, and then Vinny's come along with 1 extra. If I put them all together this time, we end up with 13 sweets. So when I try to share that out, I've now, instead of sharing it into 3 groups, I've got to try and share it between 4 people, so 4 groups. So if I start sharing that out, it looks like they're all going to get 3 sweets each. The problem is there's 1 left over. So it's an interesting one in this situation, because it's one of those situations where there's a mathematical answer, but it might not make sense in real life. In this situation, possibly we could cut this sweet up to give everyone a bit of the sweet. So some people said to me on Facebook that you would get 3 1/4 sweets each, because they're splitting that last sweet up into quarters. Spot on. Perfect. If you can cut that sweet up, that makes a lot of sense. Some people wrote it as 3.25. That's exactly the same thing as a decimal, and we'll have a look at why that is in a second. Some people, though, said they will just get 3 sweets each, and there's 1 remainder. And that's okay too, because it might be a sweet you just can't chop up and share like that. Like if we were talking about dogs, if we had an average number of dogs there instead of sweets, we absolutely couldn't cut up the last dog to share between them. It wouldn't make sense. We would have something left over. So this is a really good example of where we can get a number answer, but we do actually have to check if it makes sense in real life as well. Okay, so let's look at how we would get that answer using a calculator. I'll just show you using my calculator. You need to make sure you know how yours works, though, because not all scientific calculators work in exactly the same way. I'll talk a little to that as well. So if we want to find the mean average, we're wanting to add up all those values together. I'm actually going to pop this down here because it's getting a bit of glare up there. Right. Okay, so we're going to add all these values together first of all. So Tammy had 5 sweets, Sally had 4 sweets, Rowan had 3 sweets, and Vinny had 1 sweet. So we add those all up. At this point, we're going to get the answer to that. That gives us 13. Now I'm going to take that 13 and share it between the 4 people. So I type 13 divided by 4 equals, mine has given me 13/4. To turn that into a decimal, I can press my S to D button. If you've got a different type of calculator, you might need to go into the menu and turn it into a decimal. Mine gives me 3.25, which is the same as, and I can show you as this, 3 1/4. Okay, so we could do it that way. We could also do it all in one go. So we could type it in one go. We could put 5 plus 5 plus I'm doing it again. No, like I tell you what, I'll show you this bit first. I'll do 5 plus 4 plus 3 plus 1, and then I'll put divide by 4 equals. You might spot this gives me a different answer. That's giving me 12.25. That's because my calculator will do this divide at the end before it does the adding. So it'll prioritize the divide. So I have to tell my calculator, don't prioritize the divide. You need to prioritize the adding. In order to do that, I have to put brackets around my adding. So if I put brackets around the 5 plus 4 plus 3 plus 2 plus 1, and then the divide on the outside, it will prioritize my adding and give me the correct answer there. So we have to be really careful when using our calculator. Calculators do exactly what you tell them to do. So you have to understand what you're telling them to do, if that makes sense. Okay, this is a question from a little while ago that I used with a group, but it works really well. Unfortunately, we've only got one of these dogs now. It's about my family. It's about my husband, me, my son, and my daughter, and at the time, our 2 dogs, and our weights. So what I'd like you to have a go at, and you'll probably need a calculator for this, is to find the mean weight of our family. So to find the mean weight of our family using these values here. So we've got, this isn't actually true anymore, but it was true at the time when I wrote this question. It was about 18 months ago, I think. My daughter was at 18 kilograms. My husband was 90 kilograms. My son, 25 kilograms. Me, 60 kilograms. My big dog, 18 kilograms. And my little dog, 16 kilograms. Have a go at finding the mean weight of my family. What do you get for the mean weight of my family? Absolutely do this on a calculator, by the way. This is definitely meant for a calculator. Okay, so hopefully you've got about 37.8. It actually ends up being a really long recurring number. And I've just rounded that to 1 decimal place. So we have to find the total weight of my family by adding them all up. So 18 plus 90 plus 25 plus 60 plus 18 plus 16. That gives you 227. Because there are 6 members of the family, we would then divide that answer by 6, which gives us this really long recurring decimal. Let me just check it. Divided by 6 gives us 37.833333. So we can write that as 37.8 and then 333, and we can put some dots after it to show that it's going to keep going forever, or we could just put a dot above the 3 to show that's going to keep going forever, or we can round it, and in this case probably rounding to 1 decimal place would be accurate, and I'd need kilograms there. Now 37.8, let's just have a look at the weights of my family and see how representative you think that might be of my family. So if we look at the different weights of the people in my family, we've got 18 kilograms, 90 kilograms, 25, 60, 18 and 16. This is the mean weight, the 37.8. And I noticed something when I was looking at that. I thought, that doesn't represent a single person in this family very well at all. It is significantly lighter than me and my husband, significantly, much, much smaller. It is a lot heavier than the 2 dogs and my daughter. Closest to my son, but still quite a bit heavier than my son. And this is a really good example of how the mean can be skewed massively. We've got one person that weighs a lot more than everybody else, and one of the dogs that weighs quite a lot less as well. So this in particular, though, this is skewing the data quite a lot. This is why we need other pieces of information so that we can use the data in a meaningful way. So the other thing you can be asked to do on functional skills 1 is find the range. Now, the range is not an average, but it is often taught with averages because it's another useful piece of data to talk about averages. The range is how spread out the data is. So we want to look for the biggest piece of data, the smallest piece of data, and find out what the gap is between them. So we subtract one from the other. So here in my family, the biggest piece of data was the weight of my husband, and the smallest piece of data was the weight of my dog. So we would take this weight, the 90 kilograms, and take the weight of the little dog, 16 kilograms, and we'd take the smallest from the biggest to give us this range of 74 kilograms. And now that's a massive range, considering the biggest person was 90 kilograms. It's a huge range. And when you put that alongside the mean weight, it makes much more sense. Somebody can look at that and go, right, this is sort of the average weight, but it is really spread out. And they're going to expect some people with weights way above this and some people with weights way below this, which makes a lot more sense. Okay, so that gives somebody a lot more information. I'm going to give you some other pieces of data now. One's a women's rugby team, one's a men's rugby team. And people from the rugby teams are going to tell you some statements. I want you to see what you think about those statements. Do you agree with them? Do you disagree? Is there one of them you agree with more than the other? Have a little look now. I'll read them out to you as well. Okay. So this is the number of tries each of these rugby teams have got in their last 5 games. The women's rugby team got 2 tries, then 5, then 3, then 6, then 4. And the women's rugby team say our range is lower. That means we are more consistent. From the men's rugby team, it says the average number of tries is the same. So both teams are equally as good. And this was the men's number of tries, 1, then 9, then 2, then 1, then 7. So do you agree with them? Do you disagree? Do you think one of those statements is more accurate than the other? What do you reckon? I'll give you a little bit of time to have a think about it. This is where data gets really interesting, actually, because numbers can't lie. Numbers are numbers, but people's interpretation of them can be wildly different. When we look at the mean average for both of these, they're spot on. The men's rugby team are saying the average number of tries is the same. They're not wrong. If we add up the women's and divide it by 5, they get a mean of 4 tries per game. Same with the men. They get a mean of 4 tries per game. So the averages of them are both the same. However, with the women's rugby team, if we look at the biggest number of tries was 6, the smallest was 2. So their range, we would do 6 take away 2, which gives them 4 again. That's their range. The men's rugby team, the range would be 9 take away 1, the biggest take away the smallest, which gives them 8. So in actual fact, the women's range is smaller, so they absolutely are more consistent. There's no doubt about that. Whether you think that's a good thing or not is up to you. Your decision on this is personal, or it might be very specific to the sport or what you're doing. But we can absolutely say the women are being more consistent. If the range is smaller, they are more consistent. If the range is bigger, they are less consistent. So if we go back to these 2 statements, actually they're not wrong. Neither of them are wrong. It's just what you are looking for to whether you actually think it's a good or a bad thing. Obviously, both of them want to argue that their team is really fantastic. So yeah, their averages are the same. They've both got a mean score of 4 tries per game. So the men's rugby team, that is right. The average number of tries are the same, so they're equally as good. The women want to say we're actually better. They are more consistent because their range is lower. But on this match, the men got many, like this match and this match, they got more tries than the women. So, I suppose we could go around arguing it that way too. So both of those statements are factually true. Whether you think that is a good thing or not is entirely up to you. Okay, so those are the two things you need to know for functional skills. However, for functional skills 2, GCSE, GCSE, you also need to know about the mode and the median. Facebook, there was a couple of people that were absolutely desperate for me to sing the song, but I've forgotten it now. There is actually a song to Hey Diddle Diddle to remember what these different ones are, but I keep forgetting it. Something about hey diddle diddle, the median's the middle, you add and divide for the mean. The mode is the one that appears the most, and the range is the difference between. There we go. So that can be a helpful way to remember it if you need it. Look it up. There's someone better singing on YouTube somewhere. Definitely. Okay, so we're going to look at the mode next, which is the most. I always found this helpful to remember. They both start with mo. Most, mode. So it's the most or the most common. If we come back to our starter question, what is the average colour? If I replace the word average and I'm more specific about what type of average, and I say the modal colour, this modal is just another way of saying mode. What is the modal colour and how do I know? Well, the mode is the one that has been chosen the most often. So this blue would be the right answer there. Blue has been chosen the most often. It's got the highest bar, the highest frequency, however you want to describe it. In this case, it totally makes sense. We can pick blue for this one. We can have discrete data in the mode. What about my family? What is the modal weight or the mode of the weights for my family? Have a little look at that, see if you can pick it out. Can you spot one? There is a mode. There is a mode in this case, but it might be harder to spot. Depends how comfortable you feel with looking around for the numbers. Okay, so in this case, the mode is 18 kilograms. That's the one that comes up the most frequently. It's the only one that's repeated. Every other number is not repeated there. 18 comes up twice. No other weight comes up twice. So the mode would be 18 in this case. Again, how representative is that of the family? It's the one that comes up the most often. So maybe it makes sense, maybe it doesn't. It depends on what sort of question you want to know, I suppose. Whether you're trying to cater for us and provide us with food, it's probably really useful data to know that more people are going to be eating slightly less food because they're smaller. Depends what you're trying to answer. Right, we're going to play a little game now. It's all about mode, and you've got 3 different options each time. You can choose no mode. So if there isn't a mode, then you just choose no mode. You can choose to have one mode, and if there's one mode, then you also need an answer, which is a number. What is that mode? So you're going to give an answer as well. Or you can choose 2 modes, and in that case, you will have 2 answers to go with that. Okay, these are our only options with mode. You can't have more than 2. You can have no mode, 1 mode, 2 mode. After that, it makes no sense. We go back to no mode again. If there's more that are being repeated, we go back to no mode. Okay, right, let's have a look at this. So this one here, what is the mode? Your options are no mode, 1 mode, 2 modes. What do you think it is? And if you're answering these 2, you should have 2 answers to go alongside it. Okay, this first one, it is 1 mode. The number 1 is repeated 3 times. The other numbers, 2, 3 not repeated. 4 is only repeated twice. So the mode for this one is 1. Second one, no mode, 1 mode, or 2 modes. In this one, none of the numbers are being repeated. So there is no mode here. Next one. Can you spot it? The number 2 has been repeated 3 times, which is more than anything else. So here there is one mode, and that mode is 2. Next one, we've got red, blue, green, green, red. Is there no mode, one mode, or 2 modes? This one, there is 2 modes. We've got green repeated twice and red repeated twice. So that would be 2 modes, red and green. Next one, what is the mode on this bar chart? What is the mode colour on this bar chart? This one, there is 1 mode. It is purple because it is the highest bar. And the last one, what is the mode here? Is there no mode, 1 mode, 2 mode? Modes, I should say. And in this one, it's just 8 repeated over and over and again. That is the mode. 8 is the mode. There is 1 mode and it is 8. Okay, so we've got one more average to look at. So we've looked at mean, which is the one most people tend to think of when we talk about average, sharing it out evenly. We've looked at mode, which is the most frequent, the most occurring, the most common. The last one is the middle. What comes in the middle? So if we talk about house prices, we'll have the really expensive houses at one end, the much cheaper houses at the other. I don't think there is anything such as a really cheap house, but the much cheaper houses. And probably for most people, the most useful piece of information is actually where is the middle between those? What is the middle amount for a house, rather than it being skewed by these extreme pieces of information. So we're going to do this again. If you've got little Lego pieces or some loose parts, if you grab 7 of them and pop them in a line, they're going to represent sweets again. I probably should have just told you to bring sweets, shouldn't I? That would have been useful. So line 7 things up. Line 7 things up. It doesn't matter if there's the same things, the same colour. It doesn't matter. Just line them up for me. And find the middle one. Where is the middle one? So line 7 objects up and find the middle one. Did you find the middle one was the third one? So we sort of take one off of each side, then we take another one off of each side, then another one, and the middle one, not the third one, the fourth one. I should have said the fourth one. So this fourth one is slap bang in the middle. And we could do that with a physical objects by literally removing them. So if I've got 7 objects lined up like this, like so, and then we could just work our way to the middle. We just take away 2, take away 2, take away 2, like that. I'm going to introduce another one now. So have 8 objects lined up, 8 objects like this lined up, and find the middle one. So have 8 objects lined up and find the middle one. I've got this in a PowerPoint too. Let me just turn you around so you can have a look. So I've got 8 sweets. Which is the middle one now? Now there's 8 of them. So again, we want to do the same thing again, but this time we've got 2 objects in the middle. That is a bit tricky. So if you've got 2 objects in the middle, it can be really difficult to find the middle one. Now, we can't actually, median technically, you can't do with objects. You can't do it with discrete data. You have to do it with numbers. because we actually need to line them up from smallest to largest first. So if we've got two things in the middle, we actually need to be able to find out what is right in the middle of those as well. So if I give you an example here, if I went 1, 3, 5, 6, 9, they're in order. So we're going from smallest to largest. If I cross off the smallest, I cross off the largest. Cross off the next smallest, cross off the largest. The median is right in the middle. I've got the number 5. Now, if I have another set of numbers in order, 1, 2, 3, 5, 6, 9, and I do the same thing again. I cross off the smallest, cross off the largest, cross off the smallest, cross off the largest. Now I've got 2 numbers, and I need to find out what is right in the middle of those 2 numbers. In this case, because it's 3 and 5, it might be easy to spot that the middle number would be 4, and that would be our median. If that wasn't so easy to spot, what we could do is just add those 2 numbers up and half it to find out what's in the middle. So I could do 3 plus 5, which gives me 8. And then I take that 8 and I half it. So I do 8 divided by 2, which gives me the 4, which is our median. So if we've got 2 numbers in the middle, you actually have to find out halfway between those 2 numbers in order to find median. We also need to make sure these numbers are in order to be able to do this. The median, if you think about house prices, if I just put them a fairly average price house, a middle priced house at one end, put a really expensive house here and put the cheapest house in the middle, and then we found the median, everyone would think the cheapest house was the middle, was the average. So that would be misleading. We'd have to put them in order from cheapest to most expensive before we do it. Okay, so again, I've got some questions about the median and multiple choice answers for some of them, not for all of them, but for some of them. Okay, so what is the median here? The numbers are 1, 1, 1, 2, 3, 4, 4. What is the median in this case? Okay, so for this one, we're crossing off 1 and 4, then 1 and 4 again, then 1 and 3, and the middle number is 2. So our median is 2. The next set of numbers, what is the median? Is it 1, 2, or 4? Okay, so this one, we can't just start crossing it off. You might have noticed those numbers are not in order. So we've got to order them first. So we find the lowest numbers. We've got 2 is the lowest, and there is 3 of those. So I start off writing 2, 2, 2. The next lowest number is 4, and then 6. So I write 4, then 6. And then finally 7 and 8. So I write 7 and 8. Now I can find my median. So I cross off the lowest and the highest and keep coming in until I find my median right in the middle, which again is 4 for that one. Okay, I've got another one for you. This time I've not given you multiple choice. See how you do with this one. What is our median this time? Whoop. Little jump. Okay, so this one, there's an even number of pieces of data. So finding the median, we go to the middle and we'll find that there's an even number of numbers in the middle. So we cross off the 1 and the 8, the 2 and the 7. We're having to cross off in pairs, 3 and the 6. 4 and 5 are in the middle. So you might just know what's halfway between 4 and 5. You might know that that's 4.5 and you can just write that down. Otherwise, we do 4 plus 5, which gives us 9, and divide that by 2, which gives us 4.5 or 4.5. You might have written that as 4.5 too. Okay, I've got another one for you. Find the median of these. Whoop. I'm having a right jumpy time with my camera today. Okay, so with this one again, it's not in order. So we've got to order it first. So I'm going from smallest to largest. You could do it the other way around, actually. Largest to smallest. Do it in descending order, but I'm not going to. Right, so our lowest number is 1. So I'm going to start off with 1. Then I've got 2 twice. So I'll put 2, 2. Then I've got 3 twice. So I'm going to put 3, 3. Then I've got 6 and 7. 6 and 7. Followed by 8, 8, 9. 8, 8, 9. Now I can find my median by crossing off to get to the middle. You might notice you can cross off a couple at a time because there's enough numbers. Got the 3 and the 7, and I end up with 3 and 6 in the middle. Again, you might just be able to spot that middle number by thinking about it. Say it goes 3, 4, 5, 6. So the middle is going to be halfway between 4 and 5 again. Or you might need to add them up and do 3 plus 6, which gives us 9. And then half 9. So 9 divided by 2, which gives us 4.5 or 4.5 again. Okay, so that middle one, we had to, because there was 2 numbers in the middle, we had to add it up and find halfway between those 2. Oh, I did have one more of those. I've got one more. I thought that was the last one of those, but there's one more. There's one more. What about the median of these? So these, I showed you these with the mode as well. What would be the median here? Red, blue, green, green, red. Have you spotted it? Yeah, this one, there can't be a median for this one. There can't be a median. I know it feels tempting to cross off till you get to the middle, but I could have put those in any order. Because I can't order them, like I can't really order sweets, I suppose. I should probably have thought about that at the start. But yeah, because you can't order them, you can't find a median. It doesn't make any sense. You need some numbers to be able to order them. So median only works with numbers, not with worded or coloured or something else sort of data. Okay, we're going to end with a quiz. People seem to be liking bingo, so I'm sticking with bingo. If you've got the printout, you've got this bingo grid. If not, don't fear. You don't need it. You can just draw yourself a 3x3 grid. So just 2 lines down, 2 lines across. I'll show you the grid so you can join in. You just cross off where you see the answers. I need to be explicit at the start. If there is more than one answer, you cross off both of them. I didn't do that on Facebook, and I should have. If there's more than one answer, cross off both of the answers. Also, I don't differentiate between blue and light blue. I don't. It's just blue to me, I'm afraid. Okay, so you're using that. I'll show you the questions, and then I'll show you the grid each time. All right, I'll show you the questions, and then I'll show you the grid each time. Okay, so this is the first question. What is the modal colour on that bar chart? What is the modal colour on that bar chart? And I don't differentiate between, don't worry if it's blue or light blue so much. What is the modal colour on that bar chart? Okay, have a good look at the bar chart, and then I'm going to show you the options for answers. Options for answers. Okay, actually, I'll hold it up next to it. Hold it up next to it. They're your options for answers. 31, orange. 5, 6, 8, red. 3, 48, blue. And if you think there's more than one to answer, do cross off more than one. Hint, hint, nudge, nudge. Okay, question number 2. 5, 6, 7, 2, 1, 8, 9, 10. To find the mean, I will add the numbers up, then divide by what? What will I divide by? Shall I give you the options? Okay, there's the options. So I'm going to add them up and then divide by what to find the mean. So your options are 31, orange. 5, 6, 8, red. 3, 48, blue. Okay, question number 3. 3, 1, 5, 2, 7. The median is, and you've got to decide what the median number is here. Okay, I'll show you the options. So 3, 1, 5, 2, 7. The median is, choose which one is the median from this grid. Which one's the median? Okay, next question. Same numbers, 3, 1, 5, 2, 7. The range isn't an average, but it's an important piece of data. It's a helpful piece of data. The range is, I'll show you the options again. So on your bingo grid, which one would you cross off for the range for that piece of data? Bingo, we're looking for a line across, a line down, or a diagonal line. Another question, 11, 72, 14, 48. The median is, what is the median of that set of data? So again, here we go. We've got our grid, so you can choose from here. What's that I hear? Do I hear people shouting bingo? Bingo! Yeah, if you did, you're spot on. If you did, we should have got spot on bingo there. Okay, let's have a look at these. So the first one, this was a bit confusing on Facebook for a couple of reasons. One, people couldn't tell if they were the same height. The orange and the light blue are the same height. The other one is that I am just so far removed from being a perfectionist that I don't even think about like blue and light blue. I just put blue. So there were 2 answers for this one. There was orange and blue. So orange and blue were both the modal colour because they were both the highest. The next one, to find the mean from that set of data, we had 8 numbers. So I said you had to add the numbers up and then divide by what? Because there were 8 numbers, you had to divide by 8. The next one we found in the median. So we had the numbers 3, 1, 5, 2, and 7. They were not in order. So you needed to order them first. So we needed to put them in order from smallest to largest. 1, 2, 3, 5, and 7. And the middle number was the one right in the middle, which is 3. So 3 for that one. down here. Oh, looking close. Then I asked you to find the range for the same set of numbers. That's the difference between the largest and the smallest. 7 take away 1, which gave us 6 over here. And then finally, I asked for the median of another set of numbers that were not in order. So we had to put them in order first. So we had to go 11. Oh, I'm not doing very good at writing on that one. Let me get one of these because it's hard. It'll stay in place. We had to put them in order. So we go 11, 14, 48, and 72. The middle two numbers were the 14 and the 48. You could either just work out what the middle number is by visualizing it, or we could add those together, 14 plus 48, which gives us 62. And then we take the 62 and we half it to get our median, or divide by 2, which gave us 31. And in this case, that also gave us bingo. We could either get the diagonal or the straight line down. So that gave you bingo there. That is the end of today's lesson. I can't remember what we're doing next week. We've got 2 more weeks before Christmas. Anyway, we've got this week, next week. Oh, it might be pie charts. It might be pie charts that we're doing. I can't remember off the top of my head. But we've got 2 more weeks left before Christmas. On my YouTube lessons, because I don't have comments, I do put a post on Facebook. So if you want to say hi, head there now and just say hi. And I'll say hi back to you because it's nice to know you are here live with me. If not, that's absolutely fine. I love having you here. And hi, thank you for being part of this lesson, either live on YouTube or through the recording. That's fantastic. So I'll finish off by saying my highs to people. And then also just to let you know that I will be back this time next week doing another GCSE/functional skills maths lesson. I also do it on Tuesday at 10 o'clock. If 9 o'clock's a little bit too early for you, you can grab it there too. And I'll pop the replays on my website. So you can head to the website to grab the replays and the free workbooks at any point. Okay, right, let's quickly do this. Let's see if we've got any highs. Find my own post first. Okay, so we're just logging on. Otis wanted me to tell you he just received your cool pack in the post and he's interested in hearing more about the butterfly effect. Ooh, okay, cool. Thanks, Otis. I almost went off on one about the butterfly effect in it, and then I was like, no, Ruth, focus on weather. Yeah, no, it's cool. It is really fascinating. It's not. So the butterfly effect isn't necessarily a mathematical thing. Anyway, no, Ruth, you're going to go off on one. Not necessarily. It's like a saying or like something that's heard, but it links to chaos theory in maths. And I can definitely go off on one on that sometime. Hi, Otis. Nice to have you here. And I'm so glad you received the pack and that you're enjoying it. My 7-year-old really loved the angles session a couple of weeks ago and kept it the whole way through. We'll try averages today and see how it goes. Woohoo! Awesome! I'm so pleased you enjoyed the angles one. That's really, really cool. Yeah, I think angles are brilliant. I love angles. I think they're so accessible and enjoyable because they're so physical, aren't they? You can actually move and see what's going on. So that's really cool. I hope you enjoyed averages too. Who else? And we've got Leon. Hi, Leon. Nice to have you here, Leon. Thank you for joining me. Okay, I'm going to just refresh in case there's anyone else that says hi. And then she says, oh, I'm also live. I should say this as well. At 11:30 doing my all ages maths lesson. We're looking at animals, and today I'm looking at exoskeletons. So we're looking at the maths in animals with exoskeletons, which I started it on Tuesday. Look, Maths Mob Monkey is slowly getting an exoskeleton. We're going to add some more today. Okay. Right, I've got everyone. Perfect. Thank you so much for joining me, guys. And hopefully I will see you in another lesson very soon. Bye for now.